Okay, here we have a car accelerating along the horizontal, and our job is to find its instantaneous power at 2 seconds. Now the equation I use for instantaneous power, power is equal to force times by the velocity at that instant. Okay, so I start off with my Fab 5, and I go V1 is equal to 0. We assume it does start from rest. Velocity 2 is our question mark, and that's the one we want to find. Acceleration equals 5.2 meters per second squared. Time is equal to 2.00 seconds. And our distance is not known, and we are probably not going to need to know that. So we'll just put that as a question mark. So then I'm just going to use my V2 equals V1 plus AT equation. That will allow me to find velocity 2 without knowing distance. I guess I will solve that over here for clarity. So V2 is equal to 0 plus 5.2 multiplied by 2.00. And velocity 2 is equal to 10.4 meters per second. So I found the velocity part of this equation. And now I need to get the force applied. Now, we don't know its value. I'm going to label a force applied vector here. Reminder that this 5.2 is a velocity vector. So we do have a force applied pulling this way and a force of air going against us. So our force net equation is equal to force applied minus the force of air. Of course, I've not included gravity and normal because I know that those will cross off each other. And since we are rolling friction is very different than sliding friction. No coefficient of friction is listed. The thermal energy that we'll assume is mostly air resistance, and we will ignore any of the other types of frictions present in this case. And that's just for simplicity's sake. Now, my job is to find force applied. So I always plug in mass times acceleration, okay, for force net. So I've got 1,700 multiplied by 5.2 equals force applied minus my air value of resistance of 320. So force applied is then going to equal 9,160 newtons. Now I've got the velocity of 10.4 and force applied of 9,160. I need to find my power instant. I will just take 9,160 and I will multiply that by 10.4. And that gives me 95,300 watts. Now, just for the sake of understanding how many watts this is, I'd like to convert it into horsepower. I'm going to take 95300 and I'll divide that by 746. That's the number of watts in 1 horsepower. And that gives me about 128 horsepower. And that just gives me a little bit more appreciation of how much power is being used by this car. 128 horsepower is pretty average for a car by today's standards.